Welcome to our lesson on the comparison of electric vehicles, abbreviated as EVs. In this lesson, we will look at the different types, features, and advantages of hybrid, plug-in hybrid, battery, and fuel cell electric vehicles. Let's now look at our lesson objectives. By the end of this lesson, you will be able to name the main types of EVs in the automotive industry. Next, you will be able to distinguish between the different types of EV characteristics. Finally, you will be able to describe the advantages of each of the different types of EVs. There are two characteristics shared among all types of EVs. All EVs, regardless of type, are powered by an electric motor. The electric motor propels the vehicle's wheels and converts stored energy into motion more efficiently, resulting in higher efficiency and reduced energy waste. EVs offer environmental benefits by reducing or eliminating tailpipe emissions. Unlike internal combustion engines, abbreviated as ICE, in conventional vehicles, EVs produce little to no direct emissions, improving air quality and reducing greenhouse gas emissions. Here we have four types of EVs: hybrid electric vehicle, abbreviated as HEV, plug-in hybrid electric vehicle, abbreviated as PHEV, battery electric vehicle, abbreviated as BEV, and fuel cell electric vehicle, abbreviated as SYN-EV. These are the types of EVs in the automotive industry, and we will compare them in more detail. Please note that while these vehicles are commonly referred to as EVs, not all of them are purely electric. BEVs are the only ones that rely entirely on electricity. HEVs and PHEVs still use some form of liquid fuel alongside their electric power, while FCEVs use hydrogen gas alongside their electric power. Now, let's look at this table. It provides a concise overview of the power source for the different types of EVs. Hybrid electric vehicles, HEVs, combine an internal combustion engine and an electric motor. Plug-in hybrid electric vehicles, PHEVs, utilize an internal combustion engine with a larger battery and an electric motor. Battery electric vehicles, BEVs, rely solely on an electric motor and battery pack. And fuel cell electric vehicles, FCEVs, use a hydrogen fuel cell stack and electric motor. Next, let's move on to emissions. When comparing emissions, it's important to note that hybrid electric vehicles, HEVs, and plug-in hybrid electric vehicles, PHEVs, have lower emissions compared to conventional vehicles, while battery electric vehicles, BEVs, and fuel cell electric vehicles, FCEVs, produce zero tailpipe emissions, contributing to cleaner air and a reduced environmental impact. Let's look at driving range. When considering driving range, it's worth noting that battery electric vehicles, BEVs, typically offer a range that may exceed over 300 miles on a single charge. Hybrid electric vehicles, HEVs, and fuel cell electric vehicles, FCEVs, have ranges comparable to conventional vehicles, while plug-in hybrid electric vehicles, PHEVs, provide an electric range plus a gasoline backup. In terms of refueling or charging, conventional hybrids, such as hybrid electric vehicles, HEVs, are refueled at gas stations. Plug-in hybrid electric vehicles, PHEVs, can be charged externally and refueled at gas stations. Battery electric vehicles, BEVs, rely on charging stations or home charging, and fuel cell electric vehicles, FCEVs, require refueling at hydrogen refueling stations. When considering advantages, conventional hybrid electric vehicles, HEVs, offer improved fuel efficiency and reduced emissions compared to conventional vehicles. Plug-in hybrid electric vehicles, PHEVs, provide extended electric range and reduced emissions. Battery electric vehicles, BEVs, offer zero tailpipe emissions and lower operating costs, while fuel cell electric vehicles, FCEVs, provide zero tailpipe emissions, longer driving range, and fast refueling capabilities. Now, let's recap our lesson on the comparison of EVs. Throughout this lesson, we discussed the different types of EVs: hybrid electric vehicles, HEVs, plug-in hybrid electric vehicles, PHEVs, battery electric vehicles, BEVs, and fuel cell electric vehicles, FCEVs. First, we compared the power sources. HEVs utilize both an internal combustion engine, ICE, and an electric motor, while PHEVs have a larger battery pack and can be charged externally. On the other hand, BEVs solely rely on electric power stored in a battery pack, and FCEVs generate electricity using a hydrogen fuel cell. Next, we discuss the emissions profile. HEVs and PHEVs produce fewer emissions compared to conventional vehicles, while BEVs and FCEVs produce zero tailpipe emissions, contributing to cleaner air and a reduced environmental impact. We also looked at the driving range. HEVs and PHEVs have a longer range compared to BEVs, which are more suitable for shorter trips. FCEVs, with their hydrogen fuel cell technology, offer a range like BEVs. Then we compare the refueling or charging requirements. HEVs and PHEVs can be refueled at gas stations like conventional vehicles, while BEVs rely on charging infrastructure for recharging. FCEVs require hydrogen refueling stations. Lastly, we looked at the advantages. Remember, each EV type has its own distinct advantage. In conclusion, it is important for us to understand the unique and distinguishing characteristics that set each type of EV apart from the others. Thank you.